Okay, so in this previous lecture, what we did is I showed you a little bit how to use something that is called a version control system, and specifically one instance of version control systems, namely Subversion. And I hope what you took away from this lecture is that version control systems have two purposes. One is they record the history of a project, so that later on you can say, okay, so let's say something doesn't work today. Which of the previous changes was it that broke this? And that you can look at the individual differences between, let's say, version 14 and version 15 and say, yep, in that line, that's the problem. I remember now, I didn't think about this. So it makes it a lot easier to go back to a state where you knew it worked and compare the state from back at the time to what it is now. So the history of a project is really something that's really powerful. Maybe not so much when you're programming by yourself, but let's say if you work in a team, and in particular if you work on a project that runs for a long time, you will not remember what you did 3 months ago, and you certainly will not remember what somebody else did 5 years ago. So in bigger projects, version control systems are absolutely, they're a must. There's not a question whether you should use it, the question is just which one do you use. But I think it is useful even for your own work, that when you write your own little program, that you can make modifications and you know that you can always go back to the previous version. So of course everybody just saves individual copies of the file every few days in the hard drive, but A, you don't copy every version that you ever touch, and B, it gets to be a mess, right? It's not quite clear exactly how they were numbered. Maybe you forgot one, maybe one was deleted accidentally. A version control system keeps all of these things. So that's one of the purposes of version control, and the other one was that it allows multiple people to work together on the same project without sending around files, because there's a central place where the current state of the project is stored, and you can always get the latest version with all of the modifications everybody else made from that central location. So what I would like to show you in this lecture is two pieces. One is, well, you made a mistake, how do you undo it? You could, of course, just look at the history, look at the differences, and just undo by hand all of the edits that you made, but that's not really the way it's supposed to be done. And the other part that I would like to show you is something that is called branching and merging. And you will see later what that means, but the idea of branches is that, let's say you're working on a project with other people. You have a side project that is going to take you a couple weeks to implement, for example. And in a case like this, let's say before it's ready, you shouldn't really check in things into the current development version. So we call this mainline in Subversion lingo. So mainline is the current development version that everybody is working on. So while you're implementing things on the side on your project, you shouldn't be checking in half-finished stuff into the main repository, because it might not compile, or maybe it introduces bugs, or is not well tested, or is simply not finished. So what you do in branching is that you, let's say you copy the current state to somewhere else, and there you can add your individual commits. So you can continue to commit the changes that you made into your branch, and when it is finished, then you can merge it back into mainline. So it gives you something like a diamond pattern, right? So it comes back to mainline. I'll show you a graph later on. So that's sort of the idea of branching, and I recognize that for most of you who watch these lectures, that's probably not a common workflow, because you're, at least at the stage where you're in right now, not working with many other people. But I want to show you this because it is something that, let's say, is important for later life, but it's also important for the next lecture that I'm going to record, namely on Git, on a different version control system, because in Git we branch all the time. And so I want to, let's say, introduce you to the concepts of branches and merges. That's an important, it's a much more important concept in Git than it is in Subversion. So with no further ado, this is lecture 32.55. So the idea of version control was that it stores the history, allows you to identify the changes that broke something, and of course if you can identify something, then you can also undo it. And so I would like to show this to you, how this works in practice. So if you go back to the project that we had last time around, we had a directory project, and in there was a program that was called first program. Okay, and just to refresh your mind, so first program has gone through a number of revisions. Let me make this a little bit bigger here for you. If it's still too small, you remember that at the bottom right of the YouTube viewer, there's a gear symbol. You can click on it. You can choose a higher resolution of the video. So this project has gone from revision 1 through 13 now. Okay, and let me choose kwrite, for example. So the current state of this program looks like this. So it has 2 include files. It has a single function that outputs something. And then we added well, lines that were not particularly important for the other than as an illustration. Now let me show you something that should never happen, but I think that all of us have done many times. We found a bug somewhere in the code, and we decided to fix it at 4:58 in the evening. And of course, at 5, you need to go home. Your family's waiting. So you fixed the bug. In this case, let's say there was some missing output. Okay, so I'm going to output the missing output, and I save it, and I know it's right. Okay, so I say yes, I fixed the bug. So svn commit -m fixed the bug. John and I talked about during lunch today. There is some missing output. In fact, maybe that's not the best description, because what really should be in the commit message is, let's say, what I'm fixing, and not ancillary information like that we talked about. So let's say, fix the bug. There was some missing output. Okay, so I commit it. It gives me revision 14, and I go home. And if you paid close attention, of course, you saw that I forgot a colon here, right? It should be std : cout and not just a single colon. This happens all the time to people, and I think even good programmers know, of course, that it's a non-starter to check something in when you're in a time crunch. You should not ever be doing it. If you don't know that you have time to test it properly, then you should not be doing it. Because, of course, what happens is, let me go over to Jane's. Okay, so we had another developer here, Jane. Okay, so let's say her schedule is different. She starts at 9 in the morning. She programs till 6. So let's say at 5:05 she comes in from a meeting. She does svn update. Okay, she gets the program, and she tries to compile it, and it's not going to work. Okay, so this is why you never check something in to a public repository if you don't have time to test it. Right? It says cout not declared in the scope. It even suggests what the error is. I just forgot to test it. So what Jane is going to do is she's going to say, well, I don't know anything about this bug. I didn't find it. I have no clue what this is about. So I can't fix it. I mean, in this particular case, it's pretty obvious what the problem is, right? But let's say if you fixed something that required multiple changes in a part of the file that you're not familiar with, then Jane will not know what the fix was supposed to do, and she will not know how to rectify the problem. Okay, so in a case like this, what you will do is you will just undo the change. Okay, and so I'm going to show you how to do this in a second. But the point that I first want to make is, so we know now that revision 14 is an error, right? It doesn't compile. It will not run the test suite if you have one. So you might be tempted to say, okay, so let's just remove revision 14 from the SVN repository. Okay, well, that is a non-starter. You never change the history of a project. And the reason is, let's say, if I removed revision 14 from the repository, or let's say, if being Jane here, if Jane removed revision 14 from the repository and maybe added some changes of her own, so she added revision 14, 15, 16. If I come back tomorrow morning and I'm going to continue developing on a program, I'm going to do an SVN update. Well, SVN will tell me that the revision 14 that I have on the hard drive actually has nothing to do with the revision 14 in the repository, right? I mean, it checked out revision 14 in my own directory, right? But later on, the revision 14 that was checked out was deleted from the repository. So in a public repository, you can never change the history because you break the synchrony between the repository and your local working copy. The only thing that you can do is you can commit a revision 15 that is the exact opposite of the changes that were made between revision 13 and 14. Okay, so I would like to show this to you, how to do this. But the point I really want to stress is you never change the history of a repository, ever. Right? It is a non-starter. Okay, so let me show you how to do this. So Jane says, okay, so 14 is broken. So what she's going to do, so you see that 14 was the one that didn't work. So you say, let's go to revision 13. I just do the whole directory. Okay, so 13 actually does compile. Okay, so now I have identified which version it was that broke the problem. Okay, it could have been that somebody else checked in something on top of 14 that then, of course, also doesn't compile. But the problem really was the changes between revision 13 and 14. So I'm going to go back up to the latest version, which in this case is 14. Okay, and then I'm going to look at minus the difference between 13 and 14. So I'm going to say svn diff minus r 13 and 14. I can do it for the whole directory or just for this particular file. Okay. And it's going to show me the offending change. Okay, I could also look at the log files to find out what the problem was. Okay, so I could say svn log minus r14. Okay, that shows me so that maybe was a mistake. I should have said when I committed it who I actually am. So it shows that Jane checked it in, but that's because svn had remembered that this particular directory that I worked in was Jane's. Doesn't matter. So in reality, this would be R14 Wolfgang and then something. So this tells you who you need to send that email to or who to call up to say, I undid your change because you didn't test it. Okay. So what I need to do is I need to undo this version. And there are multiple ways to do this. So I could, of course, just go into this file here and just delete this line because I saw that this was added, or I can use something that's a little smarter. So I can say svn merge minus r14 13. So I'm going to look at the changes that I should show this to you first. So if I say diff 13 14, it shows me the changes if I start at 13 and I went to 14. But I can turn this around, of course. Okay. So if I, if I look at the differences starting at 14 going to 13, it will show that it will remove this one line. Okay, so that's what I really need to do here. So I'm going to say svn merge minus r14 13. So it's going to compute the changes between 14 and 13 and merge them into the local directory. Okay. I need a source, so I can either do this for the whole directory, okay, or I could have just done it for one particular program, let's say for first program.cc. In any case, so if I look at this file now and I need to reload this, let's say if I don't actually know how to do this with this, here, F5, okay. Well, this does not look like it is. Let's just look at this here on the command line. So you see that it doesn't show the line. my kwrite was from a different directory. That's why I didn't show it. So in the current directory, in Jane's working copy, it shows that this line was removed. Okay, that is what I get with less. Or I can also say svn-diff, and it also shows that this line was removed. Okay, and then the appropriate way to deal with this is to say svn commit -m undo revision 14 because it did not compile. Okay, so I check this in, and if I look at the svn log, it now shows 14 Jane fixed the bug. No, sorry, this is for the current directory. What I need to look at the log for first program.cc. So 15 says undo revision 14. Okay, so this is how we undo things. It's actually quite convenient to say svn, this command here, svn merge. You say the revision and where you want to, let's say from where to where. The changes from 14 to 13, which is of course the exact inverse of the changes from 13 to 14, and I want to merge that into the current directory. So this is how we deal with undoing things. So let me go back here and talk a little bit about branches. So at the end of the lecture before, I talked about the fact that I'm going to show you how to do branching. I didn't get to it, but I will actually do this now. So branches in Subversion are essentially just a copy of the main development directory. So let's say you take the current state of your development sources and you copy them somewhere else, and then you can continue to develop them with a sequence of commits, and you can merge them back because SVN tracks, let's say, where you copied your branch from. Okay, so that's the way SVN does this. So here's a graphical description. So let's say we start at revision 1. This would be something, let's say, my main line. Okay, my main line is the primary development branch, but in reality, it is just a branch like every other. Okay, it is just the one that we agree upon is the primary development line. It is, by convention, placed into a subdirectory that is called trunk in the SVN repository. I'm going to show this to you in a second. Let's say I want to develop some functionality that I can't finish it today, but I do want to check in pieces already. So I'm going to branch this. Okay, so I create a branch, and then I'm going to commit something on in revision 2. I'm going to commit something else in revision 3, and then assuming that nobody else has checked anything in here between, I can merge that back. Okay. Somebody else tomorrow might start some development here again, create a branch. Somebody else creates a third branch, commits something. The first person goes back, commits something else. Okay. Commit something else, but then decides this actually didn't work. So sometimes you just discontinue branches. You just abandon them. They continue to exist in the repository. They were just never merged back. Whereas this person here committed 7, that person committed 8 in the repository, and then you merge it back, gives revision 9. So in Subversion, revision numbers are sequentially numbered in the order in which you commit to the repository, independent of which branch you commit to. So that means that on my mainline, when you look at the history, for example, of a file, you often find that the history consists of revisions 1, 4, and 9, for example. And there are no revisions 5, 6, 7, and 8. And that's because 5, 6, 7, and 8 were committed on different branches or different files, for example. Okay? So that's sort of how we think about revision numbers in Subversion. Every time somebody commits something to a repository, it gets a new version. Okay? In the specific case of Subversion, and that is specific to Subversion. It has nothing to do with version control systems in general. Subversion essentially considers every repository like a file system. So you can think of this as, let's say, like Dropbox. Okay, it is a central repository that provides a file system with subdirectories and so on and so forth. The main development line, what we call main line, just happens to be in a directory that by convention is called trunk. But there is nothing special about this directory. It is just a top-level directory that we call trunk, and that is by convention the one where the main development happens. Whereas branches happen in directories that are called, let's say, top-level branch, and then the name of the branch. Okay. Now, in order to create a branch in SVN, what you do is you just copy the current development sources from trunk to somewhere else. Or maybe if you want to start from a branch and create a second branch, you copy the original branch into a second branch. So all of these things can be done, and basically it just means to copy a whole directory or part of the directory tree into a different directory. SVN remembers the origin of each of these copies, so that's a difference to a regular file system. In a regular file system, you only store the file. It doesn't know where it came from. But SVN does remember this, and that's important because you want to merge it back. So in order to merge it back, if you go back to this picture, if you want to merge the current state of revision 7 into a mainline, you need to know, let's say, how far back did it deviate from the main line. So you need to take the differences between version 4 and 7 and then apply them to 4 so that it gives you 9. Okay, so it's important to keep track of this. That's basically what I just told you. So let's just see how this works in practice. So I'm going to go back here, and let's say I'm in Jane's directory. I want to create a branch. Okay, so if I want to look at the repository as a file system, so I say svn info. So in this particular case, my repository is in this directory here. Yes. Well, actually, so the repository itself is in this directory here, okay? But I have checked out from the subdirectory trunk project of this repository. So you see that I was already on what I call mainline, so that's by convention in the trunk subdirectory of the repository. So the repository is something like a hard drive. Trunk is a top-level directory. So I can look at what's in this repository. If I say svnls and the name of the repository, which in most cases would be an HTTP address, for example, so you see that there is trunk, and then somebody already created a directory branches. So in trunk, there's my project. Okay. In branches, there's currently nothing. Okay. So if I want to create a branch, then I would have to say svncp for copy, okay? And I would like to copy trunk into a different location, okay? So I'm going to call this branches, let's say, I don't know, more output, because that's what this program seems to be doing. Now, I could write all of this, or in SVN there is a shortcut, so instead of having to specify the whole path to the repository, I can just say caret, so the hat here, okay, and the hat corresponds to the repository that I am currently working out of. So I have a working copy on my hard drive, and the hat corresponds to the repository from which this working copy came. So I'm going to copy here, okay. That's not what I wanted. I should have given a commit message, because copying something is the same thing as committing something, okay. So it opens an editor, which in my case is Emacs. Let's say create a branch for more output. That's my commit message. I'm going to save this. I'm going to close it. And it created revision 16. I could also have done this by saying cp -m and then in double quotes, whatever text I want to use here. Okay, so I didn't do it. I should have done it. Anyway, so if I go back to the svn-ls of the branches directory, there is now a directory that is called more output. Okay. Now, but on the other hand, so all I did is I copied something in the repository from one location to another location. If I look at svn-info for the current directory, I'm still in trunk. Okay, so I need to somehow switch my trunk to the corresponding branches part. Okay, so there is a command for this. So I could check out a completely different working copy, or I say svn switch the array branches more output. Okay, let's see if that works. Now I'm in a subdirectory project, so I need to say that here as well. Okay, so now it works. So svn-info now shows me that I am in branches more output project. Okay, so what you have now is there are 15 revisions in the there were 15 revisions on mainline, and the 16th is when I copied it to my side branch. So this corresponds to, let's say, this position. Okay, so there was some development here. This would be 15, and 16 would be create the branch. Now let me work some on this. So I'm going to add some functionality here. Okay, so output 2. I'm just going to say something that doesn't make any sense, of course, in the current context, but let's say more output, and I'm going to call this, okay, output 2. So the right thing, of course, is to test whether it at the very least compiles. Okay, it does. Can I run it? Moment. Can I run it? A.out. Yes, I can. Okay, it does what I want. So svn commit more output part 1. Okay, so it committed first program to version 17. Maybe I want even more. Even more output. I should test this again. Let's assume that I have done that. So I'm going to commit this as well. So if I look at svn log now for first program.cc, so you see that there were all of the things that happened on mainline, okay, up until 14. In 15, I undid the revision. In 16, the file was copied somewhere else. 17 and 18, I created more output. Now, let me show you something. If I add -v to this, it actually shows me which files were changed in which revision. And what you see here is in 16, it says A for add. So it created this directory here, okay, branches more output. And it says from trunk 15. So it keeps track where it copied it from and what version that thing was at the time. And that's going to make it possible to merge it back. Okay, so let's say I have done my development. It took me a week to do this. I have committed all of these things individually. Then what I would do is I go back to mainline. Okay, so in the current repository, that's the hat trunk project. Okay, I'm going to do this for the current directory. So if I say svn-info, I'm back here in trunk project. Okay, so if I reload my program now, that's what I wanted it to do earlier. So I say reload file. Okay, so I'm back on trunk. So that function output 2 is not there. Of course it's not, because on trunk I didn't commit it. I committed it to the branch. So in order to merge it, I would say svn merge. And then I need to say what branch I want to merge. So in the top level directory, branches, how was it called? Branch output, I think. More output. project. Okay, so I want to merge that branch into the current directory. Okay, and so that's what it does. So it looks at the differences from revision 15, or its copy 16 to 18, and if I reload this, there they are. Okay, so it didn't commit anything into the repository. If I say svn status, it shows that first program has been modified, and so has the current directory, and then there's the executable a.out that it doesn't know anything about. So the correct message would be svn commit -m merge branch more output. Okay, so I'm going to say that I'm merging this now. Okay, and that gives me revision 19. Now, just at the end of this lecture, let me show you a couple of things. So one of the things that sometimes happens is that you would like to go back to your branch and do some more development. So I would have to say again svn switch. Let's do this differently. So I'm just going to look at the history. So in order to switch back to the project, okay, so I go back to my branch, okay, svn info. So I'm back on the branch. I have to reload this again. Actually, it's the same, of course, now. Let's say I want to continue some more development here. So even more output. Okay, I'm going to commit this. I'm going to commit this to the branch as revision 20. Okay, and let's say I want to merge this as well. So if I go back to trunk project now, okay, so on trunk project, of course, that line is not there. So if I want to do svn, if I want to merge this again, okay, so I say svn merge from that branch to the current directory, then you can ask, well, so how does this work? So, I mean, I did something on this branch here, and I merged it, and then I continued to work on this branch. If I want to merge this again, how does it know that it only needs to merge that one additional change and not the two previous ones? And so there is a way to do this. So if you say svn prop list, so for properties, okay, prop list -v dot, that shows you properties for the current directory. Remember, we're in trunk, in the main line, okay? So there is a property that is called svn merge info that is recorded for the current directory, and it says we merged from this branch revision 16 to 18. Okay, so if I say I want to merge from this branch again, then it will know that 16 and 18 were already merged and that it only needs to merge revision 20. Okay, I can do this. I can commit, let's say, merge branches more output again. Okay, so I commit this as 21, and if you look at the properties now, you see that it merged everything from 16 to 20. Well, in reality, only 17, 18, only 16, 17, and 19, sorry, 17, 18, and 20 were the ones where I made changes on that branch. But I can write it as a range because revisions where I didn't change anything on that branch simply don't have any diffs. Okay, so this is how you work with branches. SVN is really quite comfortable in with creating branches and allowing you to merge them back into mainline. So that's a clever way of let's say committing things on the side without disturbing everybody else's development. And when you're ready with it, when you know that everything has been tested and verified and all of the functionality that you need is there, then you merge it back, and SVN makes that pretty easy. So this is how you work with SVN, and the next lecture that I'm going to show you is to use a, let's say, more modern system that is called Git. Git has many features that are similar to SVN, has some that are different. I think it is Git is more complicated to understand, and that's why I wanted to show you how things like branching in Subversion works, because it builds the foundation to understand where Git is coming from, what the concepts are, and so on and so forth.